Yeah, hello everyone. Welcome you all to the session. So here we are going to discuss the AIT 7 JEE solutions for chemistry. Okay, so let's start from the first. The IUPAC name of the given compound is. So we have two carbons and each carbon is attached with two CH3, right? So this is the compound. And here four carbon chain, straight chain is the longest chain. So 1, 2, 3, and 4. So in carbon number 2 and carbon number 3, we have two methyl groups attached. So it is 2, 3 dimethyl butane. So option B is the correct answer for this. Okay. Then coming to question number 33. When 2 mole of ideal gas heated from 300 Kelvin to 600 Kelvin at constant pressure, the change in entropy of a gas. So delta S is equal to NCP logarithmic function of T2 by T1. Okay. So the number of moles of the ideal gas is 2 and the CP value is given as 5 by 2R and into logarithmic function of the final temperature is 600 and the initial temperature is 300. Okay. So we are getting 2. So here 2 gets cancelled and we will get the delta S value as 5 into R into the logarithmic function of. Okay, so option C is the correct answer for this. Okay, then coming to question number 36, for the process H2O in liquid state when it is getting converted to the gaseous form at 1 bar pressure at 373 Kelvin, the correct set of thermodynamic parameters. And here if you check the temperature, both are in the same temperature. So both H2O exist at the same temperature. Not only temperature, pressure is also same, right? Same temperature and pressure. So at equilibrium, for same temperature and pressure, delta G should be equal to 0. Okay, delta G should be equal to 0. So option A or B should be the correct answer. And here if you see liquid is getting converted to gas. So if liquid is getting converted to gas, randomness increases. If randomness increases, entropy also increases. If entropy increases, change in entropy value should be positive. Okay. So delta G should be equal to 0 and the delta S should be positive. So option A is the correct answer for this. Okay. Then moving on to question number 37. Predict which of the following reactions have negative entropy change. So we have to find out which among the given three which are having delta S as negative. Okay. So coming to the first reaction, if delta Ng is negative, then delta S is also negative. Okay. So to find out the delta Ng for the first reaction, so here this is a liquid, so we should not consider that. And we have 1 mole of carbon dioxide and 1 plus 2. That is 3 moles of the reactant. So 1 minus 3 is minus 2. So minus 2 is the negative value, right? And coming to the second reaction, the product is a solid. So delta Ng for product, number of moles of gaseous product is 0 and the reactant is 2. So we have 2 reactant in gaseous phase. So it is 2. Again, it is negative. Then coming to the third reaction. So we have only one gaseous product. The number of moles of gaseous product is 1 and minus 0. So it is 1. So 1 is a positive number. So only in equation 1 and 2 we have negative delta Ng. So delta S will be negative over there in the first. So option C is the correct answer for this question. Okay. Then moving on to question number 38. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 20 liter. the delta U for this process is. So here the system is isothermal. If the system is isothermal, then the temperature is constant, right? Temperature is constant. If the temperature is constant, then delta T change in the temperature is 0. We know that delta U is equal to NCV delta T. So here delta T goes to 0, so delta U will be equal to 0. So because 0 into anything is 0. Okay. So option D is the correct answer for this. Clear? Then moving on to the next question 42. We have a reactant and it is reacted with HBr and we are getting products and A is the major. So we have to find out the major product. So here if you see we have HBr, this is actually the addition reaction. We have an alkene and also we have an alkyne. So alkyne is more reactive than alkene. Okay, so the addition takes place at alkyne. So one of the pi bond breaks and the negative part of the addition molecule goes to the carbon which has very less number of hydrogen. So this is Markovnikov's rule. So Br goes to the carbon which has 0 hydrogen. So it goes here and the hydrogen goes here. Okay, so we will get option C as the major product, which follows Markovnikov's addition. Okay, alkynes are more reactive than alkenes since it has 2 pi bonds. So that is more reactive, and it is the major product which is coming on from Markovnikov's addition. Okay. Then coming to question number 47, the H in H bond angle in NH3, NH4 plus and NH2 minus are in the order. Okay. So coming to NH3, the lone pair of NH3, we have one lone pair in NH3. So NH3, right? So NH3 is having one lone pair. And if you see the bond angle for NH3 is 107 degrees. Okay. Then coming to NH4 plus. So this is the structure, tetrahedral structure of NH4 plus. And here there are 0 lone pair. Since there is no lone pair, the bond angle is 109.5 degree tetrahedral bond angle. Lone pair repulsion or lone pair bond pair repulsion will not be there. Then coming to NH2 minus. So NH2 minus. So we have 2 lone pairs in NH2 minus. Number of valence electrons for nitrogen is 5 and it is gaining 1 electron. So totally 6. Out of 6, 2 has used for bonding and the remaining 4 is present as 2 lone pair. So the number of lone pair is equal to 2. And since we have lone pair repulsion, so the bond angle for H and H is 104 degree. Okay. So if you see NH4 plus is having the highest bond angle, then NH3, then NH2. So option B is the correct answer for this. Okay. Then coming to the next question, question number 52. Calculate the carbon halogen bond length in angstrom. If C single bond C bond length is 1.38 angstrom and X bond length is 0.80 angstrom. And the electronegativities of carbon and halogen are 2.5 and 3.5 respectively. So bond length is nothing but the internuclear distance, right? So we have to find this for Cx. So which is equal to the radius of the carbon plus the radius of the halogen minus 0.09 x of carbon minus x of halogen. X of halogen minus x of carbon. Okay. So RC is calculated using the internuclear distance between carbon-carbon bond divided by 2 and Rx is equal to D of Xx divided by 2. Okay, if we substitute, we will get D of carbon-halogen distance bond length will be equal to 0.69 plus 0.4 minus 0.05. So into 3.5 minus 2.5. So it is equal to 1.09 minus 0.09 into 1. So will be 1.00 answer. Okay. So the answer is 1. The bond length of carbon halogen is 1 atom. Okay. Then coming to question number 54, the electron in a hydrogen atom makes a transition N1 to N2, where N1 and N2 are the principal quantum numbers of the two states. Assume the Bohr model to be valid if the time period of the electron in the initial state is 8 times that in the final state, then the value of N1 by N2 is equal. We know that time period is equal to 2 pi r by v. And also, we all know that angular momentum mvr is equal to nh by 2 pi. So from this, v is equal to nh by 2 pi r into m, right? So we can substitute this velocity value in this time period relation 1. So the equation 1 becomes T is equal to 2 pi r divided by n h divided by 2 pi r into m, okay, which is equal to 4 pi square m by n h into r square. Now here the Bohr radius of hydrogen atom is equal to R is equal to n square h square epsilon naught divided by pi m e square. Okay. Now hence time period is equal to 4 pi square m divided by n h into n power 4 h power 4 epsilon square divided by pi square m square e power 4. So T is equal to n cube into 4 h cube epsilon naught square divided by m e power 4. Now for two orbits, we have two orbits, right? So for two orbits, T1 by 2, T2 is equal to N1 cube by N1, N2 cube. So this is the relation between time and N, time period and N. So since T1 by T2 is equal to 8, since T1 by T2 is equal to 8, because it is given that it is 8 times at in the final state, right? So it is equal to 8. So if it is equal to 8, then N1 by N2, which is to the power 3, that will be equal to 2. So N1 by N2 is equal to 2. So 2 is the ratio for N1 by. Okay. Then coming to the next question. Consider the ground state of chromium atom. The number of electrons with the azimuthal quantum numbers L is equal to 1 and 2 are respectively. So the atomic number is 24 and the electronic configuration for chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. This is the ground state electronic configuration for chromium. And L is equal to 1 denotes the p orbital and L is equal to 2 denotes d orbital. And we have 2p and 3p. So totally we have 6 electrons each. So totally 12 electrons we have for L is equal to 1. And for L is equal to 2, we have only 3d, in which there are 5 electrons. So there are 5 electrons. Okay. So the number of electrons with the azimuthal quantum numbers L is equal to 1 and 2 are 12 and 5. Okay. So here is an exception. So since chromium, when it donates one of its porous electron to 3D orbital, it is attaining the half-filled electronic configuration with 5 3D. So number of d electrons will be 5 in case of chromium. Okay. Then coming to the next question. Consider the following complex ions A, B, and C showing magnetic moments as mu A, mu B, and mu C respectively. The value of mu A plus mu B by 2 plus mu C by 2 is. So 3 compounds are given. So in the first compound, if you see the zinc is in +2 oxidation state. Zinc -4, which is equal to -2. So zinc is in +2 oxidation state. Okay, zinc is taken as an X. So Zn 2 plus. For Zn 2 plus, outer electronic configuration is 3d10 and 4 is 0, right? So we don't have electrons, so mu A is equal to 0. Coming to chromium complex, chromium is taken as X and -4, which is equal to -2. So again, chromium is also in +2 oxidation state. So chromium 2 plus is, here if you see, chromium 2 plus means it is 3d4 and 4 is 0. So here the number of unpaired electron is equal to 4. And if we substitute in mu value, which is equal to root of n into n plus 2, that is 4 into 4 plus 2. 4 plus 2 is 6. 6 into 4 is 24. And this can be written as 2 into root 6. Okay. And coming to cobalt. So here cobalt is taken as X. Ammonia as a neutral ligand. So 0, which is equal to +3. So X is equal to +3. So now cobalt is in +3 oxidation state. Cobalt 3 plus configuration is 3d, 6 and 4 is 0. And here also n value is equal to 4. N value is equal to 4, right? 5d orbitals are there. And 1, 2, 3, 4, 5, 6. So totally we have 4 unpaired electrons. And if we substitute, we will get the same value 2 root 6. 2 root 6. Now, if we add all the magnetic moment mu A plus mu B by 2 plus mu C by 2, we are getting 0 plus 2 root 6 plus 2 root 6, right? Which is mu B by 2. So it will be by 2 and by 2. So 2 gets cancelled each other. So we will have 5 as the value. So the value is coming out to be 5. The value of these two will be 5. Okay. Then coming to the next question. (44 grams of a sample on complete combustion gives 88 grams of carbon dioxide and 36 grams of water. The molecular formula of the compound may be ABC. Calculate its molecular weight. So carbon dioxide. Number of moles of carbon dioxide here is mass by molar mass. Mass is 82. Molar mass of carbon dioxide is 44. So we have 2 mole of carbon dioxide. So here 2 mole of carbon is there. 2 mole of carbon is there. And in case of H2O, if you see, the gram of H2 mass of H2O is 36. Molar mass of H2O is 80. So here also we are having 2 moles of H2. 2 moles of H2, we have 2 atoms of hydrogen, right? So 4 moles of hydrogen is there. Now, mass of carbon, hydrogen, and oxygen should be equal to 44, which implies there are 2 moles of carbon. For each carbon, the atomic mass is 12. 2 moles means it is 24. 4 moles of hydrogen means it is 4. And coming to the oxygen, it is equal to 44 and X is equal to 60. The atomic mass of oxygen is 1, oxygen is 60. So therefore, the mole of oxygen is equal to 1. So from this, the molecular formula of the compound will be equal to C2H4 and O1. So this is the molecular formula of the given species. Okay. Then coming to the question number 16, this is the last question. Among the following species N2, N2 plus, N2 minus, N2 minus, O2, O2 plus, O2 minus, O2 minus, the number of species showing diamagnetism is. So, according to molecular orbital theory, if a system is having even number of electrons, all even number of electrons, except 10 electron and 16 electron, they are diamagnetic in nature. So this is what we are getting from molecular orbital theory. Now let's calculate the total number of electrons present in each case. So in case of N2, the total number of electrons N2 is 14, right? For each nitrogen it is 7, so it is 14, which is an even number. So it will be diamagnetic in nature. And coming to N2 plus, so from 14 we have to subtract 1, so it will be 13. It is an odd number. And coming to N2 minus 14 plus 1, it is 15, again an odd number. Then coming to N2 2 minus, it is 14 plus 2, which is 16. So, but 16 is an exception. So it is also coming under paramagnetic character. So O2 is having 16 electrons. So O2 plus will have 15 electrons and O2 minus will have 17 electrons and O2 minus will have 18 electrons, which is an even number, so it is diamagnetic in nature. All these compounds, with an exception of these two, they are paramagnetic in nature. Okay, so the number of species showing diamagnetism among these 8 species are 2. Okay, the answer is 2. Okay. So I hope this session is very clear and useful to all of you. Thank you so much for watching the session. Meet you all in the next session. Till then, take care. Bye-bye. Thank you.